In this video, we're going to look at how to approximate square roots for those square roots that are not perfect squares and that we cannot memorize. Let's look at this example. I want to find out or estimate what the square root of 71 is. So the first thing I do is identify which two perfect squares 71 falls between. It falls between 64, which is a perfect square, and 81, which is a perfect square. The square root of 64 is 8, and the square root of 81 is 9. So the square root of 71 is going to be somewhere between 8 and 9. I'm going to estimate. Now, approximately where would it be? And the first thing I'm going to do is figure out what's the difference between 71 and 64. Well, 71 minus 64 is going to be 7, and 81 minus 71 is going to be 10. So my approximation, or where I'm going to start, is somewhere between 8 and 8.5, because 64 is closer to 71, so I know that my square root is going to be between 8 and 8.5. So I'm going to create a table of values, and I'm going to start with 8.3, which is a total guess, and I'm going to find the square of 8.3, which means I'm going to take 8.3 times 8.3, which is equal to 68.89. That's not close to 71 yet, so I'm going to add another tenth and try squaring 8.4 to see what I get. And 8.4 times 8.4 is equal to 70.56. I'm getting very close to 71. So I'm going to add another tenth and try 8.5. So let's square 8.5. So 8.5 times 8.5 is equal to 72.25. So now I've gone over 71. So I know the estimate for the square root of 71 is somewhere between 8.4 and 8.5. Well, which one of these is closer to 71? Well, I now need to do a little bit of math. So I'm going to take 71 and I'm going to subtract the square of 8.4, which is 70.56, and the difference is going to be 44 hundredths. And now I'm going to do the same thing with 72. I'm going to take 72.25 minus the 71, and the difference there is going to be 1.25. So the smaller difference is the difference between 71 and 70.56, which means the square root of 71 is approximately 8.4. It's not exactly 8.4. All right, the steps for approximating a square root is to first find two perfect squares that the number falls between. The second step is to make a table of numbers between the two perfect squares and find the square of those numbers. And the third step is to look for the square of a number that is the closest to the number that you are looking for. All right, let's look at another example. We want to estimate the square root of 110. So step 1 is to find which two perfect squares 110 lies between. Well, 110 lies between 100 and 121. The square root of 100 is 10, and the square root of 121 is 11. So the square root of 110 is going to lie between 10 and 11. So where am I going to start my estimate? Well, the difference between 10 and 110 is 10, and between 110 and 121 is 11. So they're fairly close to each other. So I'm going to actually start with 10.4, and I'm going to square 10.4. 10.4 times 10.4 is 108.16. I'm not at 110 yet. There's quite a bit of difference. So I'm going to add a tenth to this number, and we're going to try an estimate at 10.5. So I'm going to square 10.5, and I get 110.25. That is very close. That's actually closer to 110 than the 10.4 squared, which is 108.16. So I can say that the square root of 110 is approximately 10.5. Okay, let's look at a problem where we have to find the negative square root of 13. Because it's negative, I'm going to switch my cube roots around. So the negative square root of 13 is going to lie somewhere between the negative square root of 16 and the negative square root of 9, which means it's going to be somewhere between 4 and 3, or negative 4 and negative 3. And the difference between 16 and 13 is 3, and the difference between 13 and 9 is 4. So I can start somewhere around 3.5 or 3.4. Let's start at 3.5 because I can always change, go up or down based on what I get for this value. So let's find the square of 3.5 times 3.5, which is 12.25. Okay, so 3.5 is a little bit low, so let's try 3.6. And that would be 3.6 times 3.6, and that comes out to 12.96. We're almost there. So let's just, for the sake of checking, let's do 3.7 squared, and I'm going to get 13.69. Well, that is really far away from the square root of negative 13, so 12.96 is closer to 13, so we're going to add some negatives here and say that the negative square root of 13 is approximately negative 3.6. All right, so we can also use the approximation of a square root to determine which number is larger, or if I'm going to order rational numbers or real numbers. And in this case, I'm comparing the square root of 5 to 2 2/3. So which one is greater? Well, I need to find the square root of 5. So I've already set this up. I know square root of 5 lies between the perfect squares of 4 and 9, which means it's between 2 and 3. So 4 is very close to 5, so I'm going to start with the squaring of 2.1. 2.1 squared is 4.4. Not enough, so I try 2.2. 2.2 squared is 4.84. I'm getting very close to 5. 2.3 squared is 5.29. So the square root of 5 is somewhere between 2.2 and 2.3. So let's do some math to see which one is closer. Let's take 5 and subtract the 4.84. When I do that, I get 16/100ths. That's pretty close. If I take 5.29 minus 5, I get 29/100ths. Not as close as the 16/100ths, which means that's my best estimate, and the square root of 5 is approximately 2.2. Now, if I know square root of 5 is approximately 2.2, and I know 2 2/3 is the decimal 2.6 repeating, now I can make the comparison. 2.2 is less than 2.6 repeating. So that means the square root of 5 is less than 2 2/3.